All right, let's connect some dots. What does the gasoline in your car, the wind in the trees, and the food on your plate all have in common? Well, it turns out they all trace back to one single ultimate engine, an engine that's been running for billions of years, 93 million miles away, our sun.
I mean, really think about that for a second. The wind blowing outside, the electricity lighting up your room, even the fuel that powers our cars. It seems like they come from totally different places, right? But what if I told you they all trace back to one colossal fiery source? Okay, so to really get this, we have to go on a little trip. We need to travel to one of the most extreme environments you can possibly imagine. The very heart of our sun. The sun's core is just mind-bending. The pressure is immense, and the heat is off the charts. We're talking 15 million Kelvin. To put that in perspective, that is over 27 million degrees Fahrenheit. In that insane furnace, matter just doesn't act like it does here on Earth. And it's right there, in that cosmic soup of hydrogen and helium, that all of the sun's energy is born. So how does a star actually make energy? It's not burning, like a campfire. Nope, it's something way more fundamental, way more powerful. It's a process that literally turns matter itself into pure energy. The secret ingredient here is a process called nuclear fusion. This is what happens when the universe's most basic building blocks, the hearts of atoms, get squeezed together so hard that they fuse. They become something totally new. And in that moment of creation, an absolutely enormous amount of energy is set free. So you want to make some sunshine? Here's the recipe. You start with the most common thing in the whole universe, hydrogen. You take 4 hydrogen nuclei, you slam them together in the crazy pressure cooker of the sun's core, and what you get out is one shiny new helium nucleus. But there's a little something left over, and that something is the key to everything. And here is where the magic happens. If you could somehow weigh the ingredients before and after, you'd notice something weird. The final helium nucleus is just a tiny bit lighter than the 4 hydrogen bits that went into it. So where did that little bit of mass go? It didn't just disappear. It was converted directly into a huge burst of energy. That's the sunshine. That's the light and heat that travels all the way to Earth. Now that energy blasts out from the sun in every direction, just flooding the entire solar system. But think about how small we are and how far away. How much of that incredible power do we actually get here on Earth? Get this. The number is just staggering. We only catch about 1/2 billionth of the sun's total energy output. It's a ridiculously tiny fraction. And yet, that tiny, tiny sliver of sunlight is powerful enough to run our entire planet. So that tiny bit of energy arrives, and it doesn't just warm us up and give us a tan. No, it becomes the driving force for almost everything, changing from one form to another in this endless, beautiful, planet-shaping dance. Let's see how that works. You can see just how versatile this solar energy is. I mean, the sun's heat warms up our atmosphere, which creates differences in pressure. And what do we feel that as? Wind. That's solar heat becoming the energy of motion. Or think about plants. They use sunlight through photosynthesis to create their own food. That's solar light turning into stored chemical energy. And of course, with solar panels, we just cut to the chase and turn that light straight into electricity. But it gets even bigger than that. Solar energy is the engine behind these massive planetary systems that basically make Earth, Earth. I'm talking about things like the water cycle and the carbon cycle. Both of them are completely solar powered. Just follow the journey, right? The sun's heat lifts water up from the oceans. That water vapor forms clouds, which are basically giant batteries in the sky, holding all this potential energy. Then, when it rains, that water falls. It flows into rivers, turning potential energy into the kinetic energy of moving water, which we then use with dams to create hydropower. The whole thing starts with the sun. And the carbon cycle, it's a similar story, but it plays out over a much, much longer time. Plants breathe in CO2, and they use sunlight to lock that carbon up as chemical energy. Wood, leaves, the stuff they're made of. Millions of years ago, ancient plants and creatures died, got buried, and all that stored chemical energy got squeezed and cooked into what we now call fossil fuels. I mean, this is such a powerful way to look at it. The energy we're releasing when we burn coal or oil or natural gas, it's not new. It is solar energy that was captured by life hundreds of millions of years ago and then buried deep in the earth.
We are literally running our entire world on ancient sunshine.
So when you finally step back and look at the big picture, it becomes crystal clear. The vast, vast majority of the energy that we use, whether we call it renewable or not, is fundamentally solar energy.
This chart really helps visualize the idea. Think about our major power sources. Thermal power from fossil fuels, we just talked about it. That's ancient stored sunlight. Wind power, that's the sun's heat making the air move. Hydropower, that's the sun driving the water cycle. And solar power, obviously, that's the most direct connection of all. When you trace it all back, you realize our civilization is overwhelmingly solar-powered.
But wait, is it really everything? You might be thinking, okay, I get it, it's all from the sun. Well, as it turns out, there are a couple of major exceptions to the rule. Really powerful energy sources that have nothing to do with sunshine.
The two big ones are nuclear energy and geothermal energy. Nuclear power comes from tapping into the incredible forces that hold the nucleus of an atom together. It's totally independent of the sun. And geothermal energy, that's heat coming from inside our own planet, from the slow decay of radioactive elements that have been there since Earth first formed. These are truly homegrown energies. And that brings us to a final thought. If we start seeing fossil fuels not just as a commodity, but as this finite, ancient battery of stored sunlight, a legacy from a world that existed hundreds of millions of years ago, how does that change the way we think about using them? It connects our past, our present, and our future in one long story, all written by the light of a single distant star.